Scope was about where a name is visible in your source file. Linkage is a different question, and it is the one the linker cares about. When the same name appears in two translation units, do they refer to the same thing? There are three answers. External linkage, the default for anything at file scope, means one shared entity across the whole program. Write counter in two files with external linkage and the linker makes them the same counter. Internal linkage, which you get by writing static at file scope, means private to this translation unit. Two files can each have their own static counter and they will be two completely separate variables that never meet. And no linkage, which is everything at block scope. Your local variables are local, full stop, and the linker never even hears about them. Scope, linkage, related but genuinely independent, and it pays to keep the words apart. Here is all three in one file. Public count, at file scope with no static, has external linkage. Any other file in the program can get at it. Private count, at file scope with static, has internal linkage. Nothing outside counter.c can reach it. And another file is free to have its own private count with no conflict at all. Bump is a function at file scope with no static, so it has external linkage too. That is why you can call functions across files without doing anything special. Temp, inside the function body, has no linkage. It is nobody's business but this block's. And helper, a static function, is private to the file. Note that static is doing the same job on the variable and on the function. At file scope, static means internal linkage, which is to say private to this translation unit. One keyword, one meaning, in both places. To use public count from another file, you declare it there with extern int public count, semicolon. A declaration, not a definition. It creates nothing. It just tells this translation unit that the name exists somewhere with external linkage and leaves the linker to find it. In practice, you never write that line in a .c file. You put it in a header and include the header, so every file that uses the variable agrees about its type. And now watch what happens if you try the same trick on private count. It compiles perfectly. The compiler has no way to know better. Remember, it only ever sees one translation unit. Then the link fails with undefined reference to private count because the only thing of that name has internal linkage and the linker refuses to see it. That is static doing its job, which leads to a habit that is worth adopting today and keeping for the rest of your career. Mark every function and every file scope variable static unless another file genuinely needs it. 3 reasons, all of them real. It prevents name collisions at link time, and the collisions that hurt are with code you did not write and cannot rename somewhere inside a library. It lets the optimizer work. If a function is static, the compiler knows every possible caller is in this file, so it can inline it, or specialize it, or delete it if nothing calls it. And it documents your module. Somebody reading your file can see at a glance what the public surface is, because the public surface is the things that are not static. The cost is one keyword. It is one of the highest value habits in C, and you will see static on nearly every helper function in this book's source files.